look at what the ore looks like, fresh, broken, and close up. The split's about 2 to 1. So there's gold all through here. It's truly microscopic. How to show it to you. If you don't like parts per million, that's 0.8 grams per metric ton. Good afternoon. Today I'm going to run some ore samples through my complete process. A little micro gold extraction demonstration. These samples came from the Mojave Desert, old defunct mining claims that are no longer active. There's hundreds of gold mines out there. It's pretty easy to figure out which ones might still have some gold. This is purely a hobby. I have no interest in actually mining gold, but it's fascinating to go through the process. So let's start with the actual location. So I'll throw up a video about collecting these, and you can see where it was, roughly speaking. I'm not going to divulge the location, obviously, but you can see where it was and what I was looking for. So this is an enormous tailings pile. Very, very fine, ground to at least 100 mesh, maybe finer. There's the stonework. I imagine the mill was up there somewhere. We'll go see if we can find it. So I'm on the old road back to the mine. The mine is somewhere back there, and there's a clear road. And there's the remnants of a powder shack and everything. There's mine dumps over there. There's lots of mines back here. And this was the ore they were looking for. So here's the rock crusher I'll be using. It's a flail mill type. It uses carabiners as the flails. They spin around and crush the rock remarkably well. It uses a Makita portable angle grinder to do the crushing. So the last video I actually put up was about making this. So if you want to see how it was made and how it works, go see that video. Before I use this, I need to be able to get these rocks to a size that'll fit inside of here, and so I'll do that manually. So while we're here, let's take a look at what the ore looks like, fresh, broken, and close up. I've looked at it. It's very hard to see any signs of visual gold looking at the surface because the concentration is very low. So you can see the quartz veining structure. There were some mineralization events, hydrothermal mineralization, and we suspect that it's those events where the gold comes from. So we'll just break it up and get enough pieces to make a good test. So after running the coarse stuff back through the machine one more time, the split's about 2 to 1. So about 2/3 ends up 60 minus, and about 1/3 ends up 60 plus, and I'm going to pan them out separately. Okay, so the process goes like this. At first I use the riffles. I don't know if they help or not, but I use them anyway. Anyway, I stratify. I hold the pan so that if there's any heavy material, it's going to go down into the corner of the pan, down there. Shake to stratify, and then we'll pan off the light colored stuff. At first I can be a little more aggressive, and later I've got to be more careful. So I try to be careful not to take the black stuff from the back. When it starts to show, I just shake it down again. And as we get closer, I slow down quite a bit. So it's important at this point to make sure that the gold has been dropped to the very bottom of the corner of the pan, because it's pretty easy to start panning out the heavy stuff if you're not careful. At this point I don't like the riffles anymore. I don't know why. Anyway, I turn around and I do it this way. So there I'm shaking the material down into that corner. And you see I didn't really get a good shake that time. That's a little better. I'm just going to run the magnet all over the bottom of this thing. And I check to make sure I don't see any gold. I don't think gold comes out in this process, but you never know. Anyway, I'm going to pan it all out again, so I'm going to put it down into the tailings for right now, and it'll get a second chance. So it looks like decent ore to me, but you know, you never know. I think it fell off the turnip truck on the way to the mill. And that's about as far as I'm going to go, because I can start losing the really fine stuff if I'm not careful. Now, well, I see, I'm sure you can't see that on camera, but there are a few tiny specks of gold and maybe some like gold dust. Anyway, the next step is to snuffer this up. So in here is the cons from a previous run of the same ore. So I did 300 grams and I did another 300 grams. So this will be everything from 600 grams of ore in total. So I put the cons in here. That's from 600 grams of ore. And I just spin it around to concentrate it in the bottom of this little watch glass. And if I do it carefully, which I don't always get every time, but I can get most of the gold to settle near the very center of that concave surface. Get rid of most of the water, paper towel, and then the surface tension of the water will hold the whole thing together. But you got to get it dry or it'll run. And we flip it over and we'll take a look with the microscope. So there's gold all through here. It's truly microscopic, but maybe you can see it as I pan around and try to adjust the focus. I've looked at it visually and it's clear. There can't be very much, but there's some. So I could stop right there, having seen the gold, and I could even, I suppose, make some kind of a extremely rough estimate of how much there is. But it's a lot more interesting to try to actually separate that gold from all of this other material, and we're going to try it chemically. So let's see if I succeed this time. It's a little bit tricky when you have such little gold. I mean, I don't even know if there's a milligram, maybe less, in all of that gold. So what I'll do is I'll transfer this to this beaker. I've got this little heater here. Turned out it's not that robust, but it works. It's for the field. It runs off of a battery. And I'm using a PWM controller to set the voltage at about 7 volts, which gives me around 70 degrees centigrade, which is exactly what I was shooting for. But I don't think it's going to last that long. Okay, anyway, let's get on with it. Okay, so at the moment I've got like 10 milliliters of water, just tap water, in the beaker. And I'm going to add 10 milliliters of hydrochloric. Bring it up to 20 milliliters. And that's just muriatic acid. And so what I'm doing now is I'm actually cleaning the ore, pre-cleaning it with hydrochloric, diluted 1-to-1 with water. And I've found that helps a lot. Now I've got a little plastic tub over the whole thing to prevent the wind from cooling it, and I leave this on 70 degrees centigrade for about 1 hour. All right, it's been about a little over an hour. I've rehydrated this once, so that's the hydrochloric acid wash. I'll pour this off and rinse it out a couple of times. All right, so now we have hopefully reasonably clean gold. And I haven't thrown any away. Anyway, not yet. Okay, so I'm going to go back to starting with 10 milliliters of tap water. Yep. And I'm going to add This is, get this in the camera, right. Hydrochloric acid. There's 2. A little short of 4. That'll make 6. 8 milliliters of hydrochloric. And 2 milliliters of nitric acid. And you can see immediate change of color, huh? Oops. All right, I've maintained this. This is the concentrate in aqua regia. I've maintained this for 1 hour at 70 degrees C. And now I'm going to just strain it. And I'm going to filter it in some cotton. So this yellow fluid should have a little bit of chloroauric acid in it. Try to get as much of the gold out of it as I can. And I don't want to use any more water than necessary. I added, if you recall, I added 2 milliliters of nitric. So to kill the residual nitric that's in there, I have a saturated solution of urea, which at STP, standard temperature and pressure, which it is about today, I have 1.2 grams per milliliter of urea. And it turns out that if you use about the same amount of saturated solution of urea as you do nitric acid, then you kill all of the nitric. All right, so now I'm going to add zinc, and I've got 2 grams of zinc. 2 grams of zinc will kill about 8 milliliters of the 30% hydrochloric. A little bit less than what we should need, and that's good. I don't want to overdo it because I don't want any zinc remaining. This is granulated 20 mesh, and this will be vigorous, this reaction. And so we have to be careful not to add it too fast. So what's happening is the zinc is turning into zinc chloride. Hydrogen gas is evolved. And at the same time, gold is going to come out of the solution, but not until the very end. This is a strange reaction. So I made this mistake over and over again until I figured it out. I don't get any gold to precipitate until all of the hydrochloric is used up and I heat it for a while. Then I get a strong precipitation. So this is basically the key step, getting the gold to drop out of solution has proven to be the difficult part for me. All right, I'll just keep adding this until I've added the rest of this 2 grams. Okay, I got nearly the 2 grams in there. I'd say there's 200 milligrams left, and things have slowed down considerably. So there's still granular zinc on the bottom. And now as I heat it, and the hydrochloric gets completely used up, the gold's going to drop out of it, and we'll see a brown color. Okay, it's been about, I don't know, 3 or 4 minutes since I last shot video. Now you can see what's happening. You can see the gold is coming out of solution, and it's turning the fluid brown. So after another couple of minutes, you can see the reaction is really proceeding now. The gold is coming out of solution. All right, it's actually the next morning, and what I did was I dissolved all the remaining zinc out of it, and in doing so, it also, the hydrochloric acid dissolved a bunch of other junk. So we can call that a cleaning step. After we drop the heavy metals using zinc, then we clean it with hydrochloric, and I don't know if you can see what's left. Will it focus? There's, there's a little bit of gold on the bottom. Now, to prove that that's gold, what I'm going to do is I'm going to remove almost all of this fluid and redissolve that material that's on the bottom. I'm using aqua regia again, and we'll test it using stannous chloride. And of course, I don't want to disturb any of the material on the bottom. And this is one way to do it. So there should be the gold. I wonder if I can show you this in a little bit better way. The gold is down at the bottom. Okay, so let's dissolve this with a little bit of aqua regia. So a few drops of hydrochloric, a drop of nitric or something like that. All right. Okay, clean pipette. 1 drop. And we'll see what that does. And I'm going to have to heat it because gold doesn't dissolve in cold aqua regia. So I'll set up the heater. All right, I got the test tube and some water. The heater is on. That'll take a few minutes. All right, so just a couple of minutes. I just got it a little bit warm. It feels like body temperature. And it dissolved. Dissolved everything. Fuck. Did I miss? Well, I'm a total bloody idiot, and I have to apologize. I didn't have the camera running, or it turned itself off or something. So I have to bring you up to speed. I put the stannous chloride in here. I actually diluted it up to here. I put the stannous chloride in. It was very dark. Yeah, what a mistake not filming it, huh? And so I added water until I could get that kind of translucency because I wanted to compare it to a standard solution. So that's just 6 drops of stannous chloride plus some water in the ore sample. Now I prepared a while back, and you can look at the video, I prepared a standard solution of 1 milligram of gold per milliliter of water as chloroauric acid. And I put 5 drops of that in here, stannous chloride 6 drops, and I diluted it until I get roughly the same transparency. It's a little bit different color, but I don't think that matters too much. I'm looking at the, trying to look at the transparency of the material. I don't know how to show it to you any better, but I'm guessing that that's about the same. 5 drops of the standard solution is 1/4 of a milligram, right? Because there's 20 drops per milliliter. So 1/4 of a milliliter, it's 1/4 of a milligram. In this one, I'm saying that the transparency now is similar. That's a subjective estimate, but okay, I mean, it's what we got at the moment. And I'm saying that then this has something more than a quarter of a milligram, sorry. This has something more than a quarter of a milligram of gold. Let's say it's got a half a milligram. I mean, we're being very rough. This is not a, good quantitative test. Nonetheless, it gets the job done. So I started with 600 grams of ore, and I got, let's say I got a half a milligram. So I got basically around 1 part per million of gold in my ore sample. And that's not unexpected. So I could actually see the little particles of gold. And I showed that there was gold in the ore by chemical test, which was fun and great. This is not a way to, I mean, nobody's going to get rich collecting half a milligram of gold, but that's not the point. I'm not a gold miner. I enjoy prospecting. So let's talk about it a little bit more on paper. Okay, so let's run over what we actually did. I started with 600 grams of ore total. I ground it to roughly 60 mesh. Okay, about a third of it was larger than 60 mesh and 2/3 was finer. I panned it out in 2 steps, the coarse and the fine. Then I put it all together in a little beaker and I cleaned it with hydrochloric acid, 70 degrees C, 1 hour, and I poured off the waste. The gold doesn't go with just hydrochloric, but the hydrochloric is nice to clean the ore before further processing. And it'll remove iron and copper and some other stuff. Okay, so then I extracted the gold from that ore, the concentrates, using aqua regia. I used too much, but that's okay, we got rid of it. I used 10 milliliters of water, 8 milliliters of hydrochloric, and 2 milliliters of nitric. And I extracted at 70 degrees C for 1 hour. I then dropped the gold using zinc. I used 2 grams of zinc because 2 grams of zinc kills about that much aqua regia, actually HCl. And I did that at 70 degrees C, and it took about 10 minutes to drop all of the metals that are below zinc on the reactivity chart. And I decanted the waste fluid because now all of the gold is in the precipitate. I then redissolved the gold in the precipitate, again using aqua regia, just a little bit, with a little bit of heat. And I compared I used stannous chloride, which I didn't write here. So this is tin to chlorine donates 1, or takes 1 electron. So that's right. So I use stannous chloride to precipitate or to test for the gold. It gives you a purple color. And then I compared that with a stannous chloride test of a standard solution a gold solution that I made. And what did I find? We estimate that there's a half a milligram gold in the sample that I ran. So let's do the final calculation. 0.5 milligrams. I started with 600 grams. If I work that out, I get very roughly 0.8 parts per million of gold. And if you don't like parts per million, that's 0.8 grams per metric ton. Certainly not economically feasible, but a great sample for me to run because I've proved to myself that I can measure gold in reasonably small quantities. This might be, what, a factor of 2 off. It could be anywhere from, let's say, 0.5 to 1.5, but still, it's not worth pursuing that ore that I picked up on the road. But it was great. I hope you enjoyed the video.